In this video, we're going to look at how to differentiate trig functions, specifically the ones that you'll need for methods. And the three that we need to know are sine, cosine, and tangent. If you want to differentiate sine of some angle, where that angle is a function in terms of f of x, the derivative of sine is simply the cosine of f of x. But what we have to do on top of this is the chain rule, and I'll get into a derivation of how to get that in a different video. But in order to differentiate, you also have to times by the derivative of the inside angle, the derivative of f of x. If we want to differentiate the cosine of some function, where that function is the angle of cosine, the derivative of cosine is minus sine. So minus sine f of x. And again, we simply just need to times by the derivative of the inside function. And lastly, if we want to differentiate the tangent of some function, the derivative of tangent is 1 over the cosine of that function. Again, we have to times, 1 over the cosine squared of this function. So if we want to differentiate this, we get 1 over cosine, but then again, we must times by the derivative of the inside angle. And another way that you can see to write this is simply sec squared of f of x. Sec squared is the same thing as saying 1 over cosine squared, and you can simply times by the derivative of the inside angle, f dash x. So these are the three rules that we'll be using in this video today. So the first question I have for you is find me the derivative of sine 3x plus 2. So again, if you look at our list that we had before, the derivative of f of x, the derivative of sine x in this case, is simply going to be cosine of the angle, cosine of 3x plus 2. But here, we have to recognize the 3x plus 2 is what our f of x in this previous example would be. It'll be what our inside variable is. So just to make life easy, I'll probably change all of these to g, just so it's easier to recognize. We have g, 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 g. Okay, so back to what we were saying. If we have some function and we want to differentiate sine of that angle, we just have to times this by the derivative of the inside function. So we have to times it by 3, because the derivative of 3x plus 2 is 3. So now our derivative is simply 3 cos 3x plus 2. Okay, let's look at another example. Our next example here is going to be f of x is equal to cosine of x divided by 2. The derivative of cos x is simply going to be minus sine x. So minus sine x over 2, that's the angle, but we also have to times by the derivative of the inside angle. And what do we know as the derivative of x on 2? Well, x on 2 is the same as half x, so the derivative of this, if we were to take the derivative, is simply going to be a half. So we have to times it by a half as well. Thus, our final answer is minus half sine x on 2. Let's keep going. We want to find the derivative. We want to find the derivative of sine 2 pi x. Sine 2 pi x. The derivative of this is simply what the derivative of sine is. The derivative of sine is cos. So cosine 2 pi x, then we times by the derivative of the inside angle. So we times by 2 pi. So our final answer will be 2 pi cos 2 pi x. Next question, we're going to be differentiating sine squared of 3x plus 1. And for those of you wondering, no, you cannot differentiate this by simply saying the derivative of sine squared is cosine squared. That is not how it works. The first thing we have to recognize here before we even differentiate is we have to recognize this is the chain rule. And the reason it's the chain rule is because I can rewrite this entire statement as sine of 3x plus 1 to the power of 2. And you can recognize from my previous chain rule video, this is in the same form of some function to the power of an integer, where the function is sine 3x plus 1 squared. So to differentiate this, we bring the power to the front. We differentiate the inside bracket. The derivative of sine 3x plus 1 is simply cosine 3x plus 1, but then we also have to times it by 3. And then we keep the rest of the function, sine 3x plus 1. And then we minus away 1 from the power. So we minus 2 away from 1, we get 1. And to simplify this, it's pretty simple. We just have to do 3 times 2. So 3 times 2 is simply 6 cos 3x plus 1 times by sine 3x plus 1. And for those of you who are very astute and know your trig identities, you can simply say this is the same thing as 3 sine of 6x plus 2. And that is the derivative of sine squared 3x plus 1. Okay, the next one. We're going to have a look at x squared. So f of x is equal to x squared times by the tan of 2 pi x. So we can recognize this is one function times by another function. And when we want to differentiate this, we would use the product rule. So when we want to differentiate this, we would say differentiate the first function, keep the second, where the two functions in this case are simply going to be your x squared and your tan 2 pi x. So I differentiated the first function times by the second, and then we do the opposite. We keep the second function, then times by the derivative of the second. For methods, you would have to say divided by cos squared, but you can just say sec squared. So sec squared 2 pi x, and the derivative of tan is derivative of tan is sec squared, but we also have to times by the derivative of the angle, which is 2 pi. So now what we have to do is simplify. We can say this is the same thing as 2x tan 2 pi x plus 2 pi x squared sec squared 2 pi x. And that is the derivative of this question here. The next one we're going to do is the derivative of sine 2x divided by cos 2x. And there's two ways of doing it. The hard way and the easy way. So I'll teach you both ways. There is the hard way and there is the easy way. We'll do this way first. The hard way is to recognize this is simply a fraction with a function divided by function in terms of some input x. So we can use the quotient rule. So if we were to use the quotient rule, what we would end up saying is that the derivative f dash x is simply equal to the the quotient rule. So we copy out the denominator on both the top and the bottom. So cos 2x, and then we can square both of these. Then we have to times by the derivative of the numerator, so sine 2x. So we times by 2 cos 2x, because the derivative of sine is cos, then we simply have to times it by the inside angle's derivative. Then we do the opposite way around. We subtract away the opposite. So we can do copy out the sine 2x and then times by the derivative. So we can times it by 2 sine minus 2 sine. We can times it by minus 2 sine of 2x. That's the derivative of the denominator. Okay, so now in simplifying this, we'll get 2 cos squared 2x minus 2, or in this case plus 2 cos squared 2x divided by cos squared 2x. And for those of you that recognize, we can use our Pythagorean identity. This is the same as cos squared x plus sine squared x equals to 1. If we times both of these together, so times this by 2, times this by 2, times this by 2, the statement still holds, which is what we have in the numerator. I wrote cos for some reason, it should be sine. Whoops. Now what we get is, on the numerator, we get 2 divided by cos squared 2x. And that's how we get the derivative. That was the hard way. The easier way to do this, it's much simpler. What we can simply do is recognize that sine 2x over cos 2x is the same thing as tan 2x. Glad most of you realize this. So tan 2x, if we wanted to differentiate this, okay, the derivative is simply equal to sec squared, or in this case 1 over cos squared 2x, but then we have to times it by 2. That's the derivative of the inside bracket. And ta-da, this is much simpler. Even though they both yielded us with the same answer, this way was much, much easier. Alright, let's continue on. The next question we're going to do is work out the derivative of sine 2x times cos 3x. For this one here, there's no easy or hard method. You have to brute force it. So we see one function here times by another function here. We would simply use the product rule. So to use the product rule, the derivative of g in this case, you keep the first function, times it by the derivative of the second. So that would be minus sine of 3x times by 3, because we have to times by the derivative of the inside angle, plus the opposite way around. Differentiate sine 2x, that would be 2 cos 2x, times by cos 3x. And this is the same thing as times the 3 and the minus together, that's minus 3, so it's minus 3 sine of 2x sine of 3x plus 2 cos 2x cos 3x. And that is how you use the product rule in this question here. Let's keep going. We have 2 more problems. The next one we're going to do is f of x is equal to the cosine cubed of 3x plus 2. This here, we would use the chain rule. Again, it's similar to the other one we did, the other problem. We would simply rewrite this as cos 3x plus 2 to the power of 3. So then all we would do is use the chain rule. So what we can do is say f dash x is equal to, bring the power to the front, times by the derivative of the inside angle. So the derivative of cos is minus sine of 3x plus 2. Then we have to times by the derivative of the inside angle, which is just 3. And then we keep the remainder of the function, the original function. But then we just minus away 1 from the bracket, which is in this case 3 minus 1, or 2. Now we can simplify. We can say this is the same thing as distributing this to this and this to the 3. We can say minus 3 times 3 is minus 9. So I can say minus 9 sine 3x plus 2 times by the cosine of 3x plus 2 whole squared. Or in this case, we can also rewrite it as just cos squared. And that would be our final derivative for this problem here. Now we have one last derivative to solve. We're going to solve the derivative f of x equals to x squared sine x squared 3x. Pause the video and try this actually. Alright, good. We recognize that we have 2 functions, x squared, and then we also have sine squared 3x. So we would use the product rule. So the derivative is differentiate the first function, keep the second. Now the opposite way around. Keep the first function and differentiate the second. We can differentiate sine of 2x, sine squared of 3x, we can differentiate this by simply rewriting it as sine of 3x squared. And what we can recognize is if we have it like this, we can use the chain rule. So I'm simply just going to use the chain rule. What we can do is bring the 2 to the front. So bring the 2 here. And then times by the derivative of the inside function. The derivative of this is simply 3 cos of 3x. So times by 3 cos 3x. And then you keep the function, but then just bring it down 1 power. And I know that 2 take 1 is simply 1, and anything to the power of 1 is kind of redundant. I'm not going to write to the power of 1, so I'll just keep it as is. Now all we have to do is simplify. So we'll have 2x sine squared 3x, sine squared of 3x, plus 2x squared, not 2x squared, we have to times the 2 with the 3 as well. So you get 6x squared cos 3x sine 3x. And if you want to, we can simplify this even further, but for the purpose of this question, that is unnecessary. This is the derivative of this question here.